This will be the seventh in a series of electrical practice problems. In this video, we will again be looking at a problem related to series parallel circuits. Once I am finished with this series, I will be posting them in my stand store at this web address. Our task in this problem is to find all the currents and voltages in this network. As indicated, there are 3 voltages and 6 currents in this system. Our approach to this problem will be to first find the total resistance seen by the source and use it to find I1, and then apply Ohm's law, Kirchhoff's current law, Kirchhoff's voltage law, current division, and voltage division to determine the remaining unknown quantities. Starting at the opposite end of the network from the source, the 2K ohm and the 4K ohm resistors are in series, which give us 6K ohm. And that combination is in parallel with the 3K ohm resistor, yielding 2K ohm. And that reduces the network to this. Continuing with the same approach, the 10K and 2K ohm resistors are in series, which gives us 12K ohm, and that combination is in parallel with the 6K ohm resistor, yielding 4K ohm. Continuing with the same logic, the resultant 4K and existing 4K ohm resistors are in parallel, which gives us 2K ohm, and that reduces the network to this. Now, I1 and V1 can be easily obtained using Ohm's law. I1 is equal to 48 divided by the series resistance of 2K plus 2K, which is equal to 12 milliamps. And using Ohm's law, V1 is equal to 2K ohm times I1, or 12 milliamps, which is equal to 24 volts. Or you could use voltage division to obtain the same answer. Either way, V1 is 24 volts. Reversing the process now and returning to the original circuit, once V1 is known, 24 volts, I2 and I3 can be obtained using Ohm's law. I2 is V1 divided by 4K ohm, which is equal to 6 milliamps. I3, which is equal to V1 divided by 6K ohm, and that is equal to 4 milliamps. I4 can be obtained using Kirchhoff's current law at the node A. I1 is equal to I2 plus I3 plus I4, and we know I1 and I2 and I3, therefore I4 is simply equal to I1 minus I2 minus I3. I4 can now be calculated and is equal to 2 milliamps. The voltage of V2 is then V1 minus the voltage drop across the 10K ohm resistor times the current through it, I4, or 10 times 2, which is 24 minus 10K times 2 milliamps, which is 4 volts. Returning now to the original circuit, knowing V2, I5 can be derived using Ohm's law. I5 is equal to V2 divided by 3K ohm, which is equal to 4 divided by 3, which is equal to 1.33 milliamps. Also, I6 is equal to V2 divided by 2 plus 4 K ohm, which is 4 divided by 6, which is equal to 0.67 milliamps. Current division can also be used to find I5 and I6. Current divider rule can also be used. I5 is equal to 2 times the quantity 3 plus 4 K ohm divided by 3 plus 2 plus 4 k-ohm, which is equal to 12 divided by 9, giving us 1.33 milliamps again, and I6 is equal to 2 times 3, or the quantity 3 k-ohm divided by 3 plus 2 plus 4 k-ohm, which gives us 0.67 milliamps. Finally, V3 can be obtained using Kirchhoff's voltage law. V3 is equal to V2 minus 2 k-ohm times I6, which is equal to 4 minus 2 k-ohm times 0.67 milliamps, which is equal to 2.67 volts. The network has now been solved for all currents and voltages. This video is part of my electrical technical information series. In this series, I will be covering essential topics to help you understand electrical systems. These topics are small excerpts from my courses located in my stand store, which you can access by going to this web address. Before exiting this video, I want to make you aware of some huge sales that are coming up for members of Bluetti. Bluetti is a company that specializes in portable power stations, solar generators, and battery storage systems. It offers eco-friendly and reliable power solutions for outdoor activities, emergencies, and off-grid living. Their products include high-capacity lithium batteries with multiple outlets such as USB, AC, and DC, and compatibility with solar panels, making them ideal for providing power in remote locations during power outages. Bluetti is popular among campers, RV owners, and those seeking sustainable energy solutions. Their power stations come in various sizes and capacities, catering to different energy needs. To find out more and take advantage of this sale, simply click on this web address.